maybe that was it. Maybe it's the mix is doing that. Yeah, okay, I got it now. Yep, I know what it was. It was the little button on the audio mixer that I needed to select. All right, sorry everybody for that struggling with the YouTube feed. We now have audio, so good evening everyone. Let me have just a glass of water here. Struth. Now, I can hear myself coming through a speaker in here, so I'm just going to turn that off. It's something I still haven't fixed up. I'm still using one speaker between two radios, and RF gets into the speaker lead if I'm on 80 meters. It's one of these painful little episodes I've got here. Let's get into it. Good evening, everybody. And as I was saying to the folks up there at the Parkes Radio Telescope, if you're watching the YouTube stream tonight, I trust that everybody is well up there and that today's tour went well, and I believe it did. So look forward to hearing some feedback on that one. Okay, Sky Notes for February. Thank you, Tanya Hill, courtesy of Tanya Hill, astronomer, professional astronomer Tanya Hill. Okay, what's happening at the moment? Let's see. There's a comet in our skies. Comet ZTF is in our skies. If you are lucky enough to be under the dark country skies between 6th and 14th of February, there's a chance you'll see Comet ZTF C/2022 E3. But don't expect anything too spectacular, as the comet will only just be bright enough to be seen with the naked eye. It will be in the northern sky between 10 and 11 p.m. and to our eyes it will appear as a small fuzzy blob, while binoculars or telescopes can reveal much more. Comet ZTF was last near Earth 50,000 years ago. It comes from a reservoir of comets known as the Oort cloud that exists in the outermost reaches of the solar system. There are over 3,700 known comets. At any time there can be a dozen of comets in the sky, but it's only on the rare occasions when a comet becomes bright enough to be visible that they are widely publicized. And while the position of a comet can be known with great precision, just how bright a comet will become is hard to predict. It depends on not only on the size of the comet, but how it behaves as it passes the sun. Ideally, the comet breaks apart enough to create a lovely bright tail, but not too much of there's chance it will disintegrate completely. Now, they've got a picture here of a couple of comets that have been and gone in the past. I'll see if I can quickly bring those up onto the screen. Okay, that's Comet McNaught on the left, for those watching the YouTube channel. Comet McNaught is seen over the Pacific in 2007, and the one on the right, of course, is Comet Halley, as seen by Rosetta probe in 2008. Just as an example of a couple of comets that can be visible in our skies. There's also another image here, which is Comet Hale-Bopp in 1977, with a dust tail on the right and a blue iron tail above. And I remember, I think, I'm not sure if it was Comet Hale-Bopp that I saw here from Dandenong, but I know there was a comet, I think it was Hale-Bopp, can't quite remember right now, but there was one that was fairly visible in the southern southwest sky, and I remember filming it with a video camera. It was that easily to see. So continuing on with Tanya's notes, she says the next question is, what does Comet ZTF look like? For January images and time-elapse video of Comet ZTF, she says, see Michael J. Gar's social media posts. I guess it'll be on Facebook. However, there is a photograph, and I do have an image here of ZTF here. There it is. Okay. So that's kind of like the current images coming through from photography. A lot of what you will see of Comet ZAF by eye isn't going to show you the kind of detail that a photography will show you. So in these two images on the YouTube channel, you if anybody's looking, you'll see that's how much you'll see of the comet at the moment. Very greeny, sort of a glow, a blob is another term for it, I guess. But anyway, there's a lot of photographs taken from the northern hemisphere clearly show the comet's coma and tails, including astrophotography and images processing details. So where is it travelling? Well, Comet ZTF's perihelion, how close it gets to the Sun, was on the 12th of January at 166 million kilometres and has been observed by professional and amateur astronomers in the Northern Hemisphere. However, it will be at its brightest on the 1st of February when it makes its closest pass by Earth, reaching 42 million kilometres away, or about a third of the distance to Mars. It won't be visible in the Southern Hemisphere until the week later, when it will start to fade. So, like I say, the window of opportunity to see this comet is a little on the narrow side. A good time to see the comet will be the night of the 11th of February, as the comet will be just to the right of Mars, and on the 14th and 15th of February, it will be close to the red giant star Aldebaran in Taurus. Remember, dark viewing conditions are the best, and binoculars are recommended too. So, so the best time to see Comet ZTF will be mid-February, let's say the dates of 14th and the 15th, and try to identify the constellation of Taurus. My suggestion is to, I know there's many apps that you can put on your mobile phone, many apps that will that will display the stars above you. And because most mobile phones have GPS operational aspect to it, as you move the mobile phone above your head, the stars will track according to the position of your mobile phone. So you hold your mobile phone above your head, and directly above you will be a representation of the star map against the real sky. It's quite an amazing technology. I think when I first saw that on a mobile phone about 20 years ago, I was sold straight away. But that doesn't mean that the traditional way of doing it, of course, is using star charts, which you open up by hand, and you've got physical paper in your hand, and there it is, a map of star charts, or stars, that you can put above your head and do it that way. That's how we all started out. Anyway, I'm going off on a tangent here. So nevertheless, Aldebaran in Taurus and is the spot to look for in the evening. Comets are named after their discoverer, and Comet ZTF was discovered by Zwicky Transit Facility. Zwicky, that's Z-W-I-C-K-Y, Zwicky Transient Facility, ZTF, in March 2022. The ZTF is an automated telescope in California that maps the entire sky every 2 nights, looking for things that change, i.e. transients, such as comets, asteroids and supernovae. It is really only in the photographs that the true spectacle of Comet ZTF can be enjoyed, particularly its colourful features such as the green coma. Comets often glow green because of carbon. Comets contain organic matter, the stuff of life, and sunlight, UV, breaks down the complex organic material into simple carbon ions. These glow green when they drop from a high energy or excited state to a lower energy state. Blue ion plasma trail is made of charged particles created by solar wind blasting the comet. The ion tail is very straight and always points directly away from the sun. In a similar process to the green coma, the ion tail glows blue due to the excited nitrogen-carbon monoxide ions. And there is a picture of that, which I did show before. but I shall just go back to it. There it is. It's Comet Hale-Bopp. Comet Hale-Bopp. So you can see the blue trail of ions there, and of course the other trail as a result of the organic matter that's being produced as the gets closer to the sun. Then there's also a dust tail, and it is the classic comet of an image of a comet. As a comet sublimates, turns from solid to gas, dust particles are released, and some of these are so light that they are pushed away from the nucleus by beams of sunlight, also known as radiation pressure. The dust tail points away from the sun, but it is curved and broad because of the very gentle force on particles. Orbital debris and any larger, heavier dust grains that are released remain in orbit, littering the comet's orbit like breadcrumbs. This is how we get meteor showers, which occur when Earth passes through a debris field left behind by a comet. So a lot of the meteor showers that are scheduled on the calendar are principally a result of that, the Earth going through the debris field of these comets, and it really is quite amazing. So why are comets dynamic, you might ask? Comets are icy dirt balls or dirty snowballs that orbit far from the sun in deep freeze. But should they arrive in the inner solar system, they become dynamic visitors. They are heated by the close approach to the sun. They interact with the solar wind and sunlight. They can also disrupt by larger solar events, be disrupted by larger solar events. In January, the comet ZTF underwent a disconnection event. A piece of the comet's iron tail was hit by a plasma from the sun, known as a CME, or coronal mass ejection, which disturbed the smoothness of the tail. I actually mentioned that last week, and I think I did have a picture of it, but I didn't run the video last week, so I won't worry about that right now. Alright, so enough of comments. Let's go back to the camera. Alrighty then. So, sunrise times for February. Wednesday being the 1st of February, we had sunrise at 6:33 and setting at 8:33. On Saturday the 11th, sunrise will be at 6:44, setting at 8:23. On Tuesday, the 21st, sunrise will be at 6:56, setting at 8:11. And by the end of the month, Tuesday the 28th of February, sunrise will be at 7:02 and setting at 8:02. So our evenings get progressively shorter or longer, depends on your point of view. But anyway, the day gets shorter, starting out at 14 hours and ending at 12:59 hours for the average day length. Moon phase. There's a full moon on Monday the 6th, this Monday. There's a third quarter on Tuesday the 14th. There's a new moon on Monday the 20th. And there's a first quarter on Monday the 27th. The moon will be furthest from the Earth on Monday the 4th at 406,476 kilometres. And then it will be closer to Earth, at its closest point to Earth, on Sunday the 19th of Feb at 358,207 kilometres for those doing moon bounce. Visible planets. Mercury is very close to the Sun this month, but it will be briefly visible in the early dawn light from 4:40 a.m. and a little earlier each morning before fading by sunrise. It will soon pass behind the Sun to reappear again in the mornings in May. Venus is back as the evening star in the west from about 8:40 p.m. and setting shortly after by 9:30 p.m. with those timings a little earlier each evening. Mars continues bright and clear in our evening skies, visible from 9 p.m. in the north in early February and setting by 1 a.m. during the month, it too can be seen a little earlier each night. Jupiter remains in the west from 8:40 p.m. and sets by 10:30 p.m. It's in its slow orbit around the Sun. The Jovian giant is heading to pass behind the Sun, pass behind the Sun in solar conjunction in April. Saturn is too close to the Sun to be seen this month. It will shortly pass behind the Sun in its solar conjunction and then return to our night skies in mid-March. That's the planets. Meteors. The Alpha Centaurids and Beta Centaurids are active from the 2nd of Feb to the 25th of Feb, peaking on the 8th. They are different, but it is difficult to distinguish between them. Occurring low in the south near the 2 pointers, they are not strong showers, but often have fireballs and persistent trails. It is known that 25 per hour can occur, but 6 per hour has been the usual. So that's the Alpha Centaurids and the Beta Centaurids looking towards the Southern Cross for the whole month, really. Okay, and let's see. Constellations. Okay, stars and constellations. In the east, looking towards the east, high in the sky is Sirius, the brightest star at night, and principal star in Canis Major, the greater dog. This is one of Orion's 2 hunter dogs, which is why Sirius is also referred to as the dog star. Many cultures have recognised the first evening appearance of Sirius as marking a special time during the year for religious, agricultural or other reasons. It sits 8.6 light years away, making it the 5th nearest system to us. In fact, I've got a picture here of Sirius that I did download. There it is. That image there is the Hubble Space Telescope looking at this Sirius A. Can barely read that, but that's a Hubble Space Telescope image of that star. And so it's, as I say, it sits 8.6 light years away, making it the 5th nearest system to us. It is more than 25 times as luminous as the Sun, with a name appropriately derived from the Greek Sirios, or glowing or scorching. Sirius is, however, a binary system, with the main star Sirius A, twice the mass of our Sun, and 24 million kilometres in diameter. By comparison, our Sun is 1.39 million kilometres in diameter. 24 million kilometres in diameter, and our Sun's only 1.39 million kilometres. I'm always dumbfounded by the size of some of these stars in the universe. The small companion Sirius B is a white dwarf and only 12,000 kilometres in diameter. 12,000 kilometres? Anyway, it is remnant core of a star not unlike our Sun. Sirius A and B orbit each other, their mutual centre of mass, every 50 years. In this Hubble Space Telescope, which is on the screen right now, image, Sirius B is the white dot at the lower left. If you can, oh yes, oh right, okay, got it. Yeah, okay, maybe that is only 12,000 kilometres across. So Sirius A is the little white dot. Sorry, Sirius B, the image. In this Hubble Space Telescope image, Sirius B is the white dot at the lower left, some 10,000 times fainter than Sirius A at the centre. In terms of angular separation in this image, the two stars are a little over 6 arcseconds apart, which required fine observing to identify as the light of Sirius A swamps Sirius B. So there it is. All right, isn't that interesting? I think so. All right, back to me. Okay, in the north to northwest, directly north lies Orion, the hunter, seen in the southern hemisphere upside down. The famous 3 stars of this belt are Mintaka and El Nilam and El Nitak. Latin names. From his belt and going upright is a line of stars which forms his scabbard, or sword, in the centre of which is the beautiful Orion Nebula. And when it comes to astrophotography, the Orion Nebula is a very popular point to point your telescope to take pictures. Some of the gaseous nebulosity of that area is just, it makes some absolutely amazing photographs. Anyway, a vast stellar nursery of 15,000 light years from us. Upper left in the Rhine is the blue-white supergiant star Regal, one of his feet, and the lower right is the red star supergiant Betelgeuse, one of the shoulders. Orion's three belt stars also make the base of the Saucepan asterism. The open star cluster, the Hyades, an open star cluster 153 light years away, forms the inverted V of the head of the Taurus, the bull, with the red giant star Aldebaran sitting at its lower right corner. To the left, just above Mars this month, is Pleiades, a close cluster of young blue stars 430 light years from us. These stars are formed together and are generally bound together under their mutual gravitational attraction, although over millions of years it is expected the cluster will disperse. Also known as the Seven Sisters, and for many cultures across the world they represent a group of women. The cluster is M45 on the Charles Messier star catalogue. And the Pleiades is also a magnificent region of the sky to look at through any telescope. It was really quite bright, those stars. In the southeast to the southwest, looking southeast to southwest, the Southern Cross and the two pointers, Alpha and Beta Centauri, are low in the southeast. In the southwest are the two small nearby galaxies, the Magellanic Clouds, named in honour of the 16th century explorer Ferdinand. That's his first name, Ferdinand Magellan, who embarked on the first circumnavigation of the globe. They look like faint fuzzy patches, but are best seen away from city lights. They are visible all year round, unlike the equivalent latitudes in the Northern Hemisphere, where they cannot be seen. Another term for that is circumpolar, where they don't go below the horizon. They just circle in the sky around the southern pole part of the sky. The earliest known physical depictions of them are the petroglyphs and rock art in South America. Arcing across the night sky and slowly wheeling as the Earth rotates during the night to the east is the majestic Milky Way, billions of distant stars of our own galaxy, which in a dark sky site or away from a city you can clearly see by eye. It's absolutely amazing. In visible light, our view of the galaxy is largely restricted to our local spiral arm, which is one of several that sit in the disk of the galaxy. We are looking edge-on into the flat disk of billions of stars. In those directions, we see far fewer stars for only a few thousands light years beyond which lies the intergalactic space. And it was through radio astronomy that we discovered that we had a spiral galaxy. Okay, the International Space Station. Time is 29 past 10. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. The ISS orbits every 90 minutes at an average distance of 400 kilometres. It appears like a bright star moving slowly across the night sky. Some bright passes are below the Melbourne region. On the morning of Thursday the 9th, there's a passing at 5:57 a.m. to 6:04, coming in from the southwest to the northeast. On Friday the 10th of February, there's a passing starts at 5:08 a.m. and to 5:15 a.m. southwest to east-northeast. And then on the evening of Friday the 10th, there's a passing at 9:49 to 9:53 north-northwest to east. And on Monday the 13th of February in the evening, there's a passing at 8:57 p.m. to 9:04 p.m. northwest to the southeast. As she says here, note that the two brightest passes for February 10, one in the morning and one in the evening. So, but that's just some of the main passes. For more detailed information on the passes of the International Space Station, visit Heavens Above, the website Heavens Above, which gives predictions for visible passes of the space stations and major satellites, live sky views and 3D visualizations. And be sure to type in your exact location for the star maps to work more accurately for you. All right, at 10:30, I'll just run through. There's a few important dates here, but I won't go through them all. On the 1st of February, 2003, the Space Shuttle Columbia disintegrated on re-entry, killing all 7 astronauts and halting the shuttle space program for over 2 years. Also on the 1st of February 1970, US astronomer Vera Rubin finds evidence of dark matter by studying motion of stars and galaxy rotation not consistent with Newton's laws. On the 3rd of February 1996, Luna 9 made the first soft landing on Moon and sent the first panoramic images from the ocean of storms. On the 4th of February 1976, the Lunar Orbiter 3 launches to the Moon to select Apollo landing sites. On the 5th of February 1963, Dutch astronomer Maarten Schmidt discovers quasars, or quasar-stellar radio sources, exceptionally bright radio sources. On the 7th of February 1979, Pluto moves inside Neptune's orbit for the first time since 1930's discovery. On the 8th of February, I forgot to mention my email address. Just saw an email pop up on the screen. On the 8th of February 1969, the Allende meteorite, the largest carbonaceous meteorite found, lands near the village of Allende, Mexico. Right, okay. On the 9th of February 1986, the last visit of Comet Halley met by a flotilla of probes, with Comet's next return due in mid-2061. I don't think I'll be around for that one. Also on the 9th of February 1473, the birth of Nicholas Copernicus, never mind, you know who I'm saying, famous for his sun-centered theory on the revolutions of the celestial spheres in 1543, which triggered the Copernican revolution. I'm not saying that right. I can say it in my head, but it doesn't come out Copernican. Anyway, also on the 9th of February 1975, Soyuz 17 returns to Earth, setting Soviet record for 29 days in space. And one more date, on the 11th of February 2003, the first measurements using WMAP, Wilkinson microwave anisotropic probe, data to reveal relic Big Bang temperature as a variation across the universe. Amazing stuff. You're tuned to ASV Radio, VK3 EKH, coming to you from the studios of VK3 CSJ in Narre Warren South. We also have an email address if anybody wishes to send signal reports, as one just did. Our email address is vk3ekh@gmail.com, vk3ekh@gmail.com. And I can actually see there's already a few emails there which I've just picked up on. We also have a chat window, Discord chat window, which can be accessed via the ASV website under the Radio Astronomy tab and look for the broadcast, Radio ASV broadcast link. So good day to Andrew, VK3KIS. He says Happy New Year. And Don, VK3 HDX, also says great signal on 80. And Stephen, VK3 SPX, also giving us a report. And Ian, VK3 VIN. No worries there, Ian. Thank you very much. Thank you very much. All right, next on the agenda to read it tonight. Oh, getting dry in the mouth here. I can hear it's raining outside. Oh, I can't see what the temperature is. Oh. Just excuse me a second, I'm off the microphone. Just checking the outside temperature. It was 12 degrees. Sorry about that. James Webb pierces the cold heart of Chameleon. What is this all about? By observing distant stars through a star-forming cloud of gas and dust, Webb is helping astronomers map out the complex chemicals that could form life. Stars form when massive clouds of cold gas and dust fragment, condense and collapse. As the density in a small part of the cloud grows high enough, the pressure skyrockets until it ignites the fusion process that forms the fiery heart of new stars, or a new star. As the nascent star grows, it becomes encircled by a protoplanetary disk made of the same material that formed the star. This disk is what eventually gives birth to the planets, asteroids and comets around the new sun. This gorgeous new image from the James Webb Space Telescope, JWST, features the molecular cloud Chameleon. I don't think I saved that image. Or did I? No, it's not there. So my apologies, I haven't got that image. You're just going to have to take my word for it. Anyway, so this gorgeous new image from the James Webb Space Telescope, and you can actually, if you go visiting the astronomy.com website, you'll find it there. Astronomy.com, under the news tab, and look for James Webb pierces the cold heart of Chameleon, and that's the picture just there. Anyway, so it says one of the nearest star-forming regions to Earth. It is located just 626 light years away. At the upper left is a young protostar called CED 110IRS4, whose light illuminates the dense bluish cloud at infrared wavelengths Webb observes. Just visible through the cloud at the centre are several small point-like background stars, mostly obscured by the cold material. But these stars are the cornerstone of a new study which used JWST to decode the chemical composition of ices within the Chameleon. And here's how the study worked. As starlight from those background stars filters through the cloud, some of the light gets absorbed by the ices. By splitting apart the light that makes up it through the cloud using a technique called spectroscopy, astronomers can look at which specific wavelengths are absorbed. This lets them determine which atoms are responsible for absorbing each specific wavelength. In this case of Chameleon, they identified ices inside the cloud such as water, carbon I, sulfide, ammonia, methane and methanol. Researchers also found hints of even more complex molecules such as ethanol. Webb's new view of Chameleon is the most comprehensive look at ices within such a dense molecular cloud to date. The observations are providing astronomers with important information about the particular molecules that are available to form new planets and any life that might eventually evolve on them. The results suggest that planets can essentially inherit already chemically complex molecules straight from molecular clouds. They also hint that at the possibility that such complex molecules, which are essential to life on Earth, are widespread. They are not unique to the protostellar cloud that formed our sun and planets. However, the Chameleon observation still revealed far fewer available building blocks in the ices that astronomers expected the cloud to contain. And this means that in addition to being locked up in ices, elements such as carbon, oxygen, nitrogen and hydrogen and sulfur also likely exist as sooty or even rocky material within the cloud. Webb alone Webb alone was able to do this work, as Chamaeleon is so dense and cold that most of the background starlight gets absorbed. Only faint infrared wavelengths can pierce through it. The new observations are part of the Ice Age project, which is using JWST to look for building blocks of life to help determine how common or rare life might be in the universe. So stay tuned, because more surprises are to come from the James Webb Space Telescope, and I have no doubt about that. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Very pleasant good evening to Remus. He's on the chat window there. Remus and Martin, VK7JAH, up there on the chat window. Only a couple of fellows up there at the moment. But anyway, g'day Remus. Okay. Next. The first stars may have been heavier than 100,000 suns. 3rd of February. This is courtesy of Science Alert, www.sciencealert.com. Let me just check that size of that article. Yeah, that should be all right. There is an image here too. I did have this image. I did save this image. So I'll bring that up on the screen. Okay, so as the article goes, the universe in the beginning... my mind going off on a tangent straight away. The universe was simply different when it was younger. Recently, astronomers have discovered that complex physics in the young cosmos may have led to the development of supermassive stars, each one weighing up to 100,000 times the mass of our own sun. We currently have no observations of the formation of the first stars in the universe, which is thought to have taken place when our cosmos was only a few 100 million years old. To understand this important epoch, astronomers turned to sophisticated computer simulations to test out models of how the first stars formed. Over the years, astronomers have wrestled with the key question of what is the typical size of the first stars. Some early estimates predict that the first stars could be hundreds of times more massive than the Sun, while later simulations suggested that they would be more normally sized. Recently, a team of researchers have put together a new round of simulations and come to a very surprising conclusion. Their simulations specifically looked at a phenomenon known as cold accretion. To build large stars, you have to pull a lot of material into a very small volume very quickly. And you have to do it without raising the temperature of the material, because warmer material will prevent itself from collapsing. So you need some method of removing heat from material as it collapses very quickly. Earlier simulations had found the appearance of dense pockets within early galaxies that cool off rapidly from emitting radiation, but did not have the resolution needed to follow up their further evolution. The new research takes it a step further by examining how cold, dense pockets that initially form the early universe behave. These simulations revealed that large flows of cold, dense matter can strike an accretion disk at the center of the giant clumps of matter. When that happens, a shock wave forms, and that shock wave rapidly destabilizes the gas and triggers the instant collapse of large pockets of matter. Those large pockets can be tens of thousands of times more massive than the Sun, and in some cases even 100,000 times more massive than our Sun. With nothing to stop their collapse, they immediately form gigantic stars known as supermassive stars. The astronomers do not know if supermassive stars formed in the early universe. They hope that future observations with the James Webb Space Telescope will reveal clues as the formation of the first stars and galaxies determine if these monsters appeared in the faint infant universe. And the image you see there on the screen, they didn't really make any reference to it, but it's a visualization of the universe during the epoch of reionization. There it is. Yes. 15 minutes to go. ladies and gentlemen, then I'll be out of your hair. All right, where's the next article? Oh, yeah, okay. Did I have anything saved from there? I don't think I did. All right. Actually, I think... Oh, no, this is a relatively short article. Artificial intelligence is helping hunt for extraterrestrial life, and it's found 8 strange new signals. Artificial intelligence, or AI's ability to identify techno-signatures missed by classical algorithms, is an exciting step forward for radio astronomers. If I can ever have a radio astronomy article, I will. Some 540 million years ago, diverse life forms suddenly began to merge from the muddy ocean floors of planet Earth. This period is known as the Cambrian explosion, and these aquatic critters are our ancient ancestors. All complex life on Earth evolved from these underwater creatures. Scientists believe all it took was an ever so slight increase in ocean oxygen levels above a certain threshold. We may now be in the midst of a Cambrian explosion for artificial intelligence. In the past few years, a burst of incredibly capable AI programs like Midjourney and DALL-E 2 and ChatGPT have showcased the rapid progress we've made in machine learning. AI is now used in virtually all areas of science to help researchers with routine classification tasks. It's also helping our team of radio astronomers broaden the search for extraterrestrial life, and results so far have been promising. As scientists searching for evidence of intelligent life beyond Earth, we have built an artificial intelligence system that beats classical algorithms in signal detection tasks. Our AI was trained to search through data from radio telescopes for signals that couldn't be generated by natural astrophysical processes. When we fed our AI a previously studied data set, it discovered 8 signals of interest the classical algorithms missed. To be clear, these signals are probably not from extraterrestrial intelligence, and are more likely rare cases of radio interference. Nonetheless, our findings, published Jan 30 in Nature Astronomy, highlight how AI techniques are sure to play a continued role in the search for extraterrestrial intelligence. AI algorithms do not understand or think. They do excel at pattern recognition and have proven exceedingly useful for tasks such as classification. But they don't have the ability to problem solve. They only do the specific tasks they were trained to do. So although the idea of an AI detecting extraterrestrial intelligence sounds like a plot of an exciting science fiction novel, both terms are flawed. Artificial intelligence programs are not intelligent, and searches for extraterrestrial intelligence can't find direct evidence of intelligence. Instead, radio astronomers look for radio techno-signatures. These hypothesized signals would indicate the presence of technology, and by proxy, the existence of a society with the capability to harness technology for communication. For our research, we created an algorithm that uses AI methods to classify signals as being either radio interference or a genuine techno-signature candidate. And our algorithm is performing better than we hoped. So what does the AI algorithm do? The techno-signature searches have been likened to looking for a needle in a cosmic haystack. Radio telescopes produce huge volumes of data, and in it are huge amounts of interference from sources such as phones, Wi-Fi, and satellites. Search algorithms need to be able to sift out real technosignatures from false positives. Our AI classifier delivers on these requirements. Wrong one. It was devised by Peter Ma, MA, at University of Toronto, student and the lead author on our paper. To create a set of training data, Peter inserted simulated signals into real data and then used this dataset to train an AI algorithm called an autoencoder. As the autoencoder processed the data, it learned to identify salient features in the data. In a second step, these features were fed to an algorithm called a random forest classifier. This classifier creates decision trees to decide if a signal is noteworthy or just radio interference, essentially separating the technosignature needles from the haystack. After training our AI algorithm, we fed it more than 150 terabytes of data, 480 observing hours from the Green Bank telescope in West Virginia. It identified 20,515 signals of interest, which we then had to manually inspect. Of these, 8 signals had the characteristics of technosignatures and couldn't be attributed to radio interference. So, to try and verify these signals, we went back to the telescope to re-observe all 8 signals of interest. Unfortunately, we were not able to re-detect any of them in our follow-up observations. We've been in similar situations before. In 2020, we detected a signal that turned out to be pernicious radio interference. While we will monitor these 8 new candidates, the most likely explanation is that they were unusual manifestations of radio interference, but not aliens. Sadly, the issue of radio interference isn't going anywhere, but we will be better equipped to deal with it as new technologies emerge. So, in narrowing the search, our team recently deployed a powerful signal processor on the Meerkat telescope in South Africa. Meerkat uses a technique called interferometry to combine its 64 dishes to act as a single telescope. This technique is better able to pinpoint where in the sky a signal comes from, which will drastically reduce false positives from radio interference. If astronomers do manage to detect a technosignature that can't be explained away as interference, it would strongly suggest humans aren't the sole creators of technology within the Milky Way. And this would be one of the most profound discoveries imaginable. At the same time, if we detect nothing, that doesn't necessarily mean we are the only capable intelligent species around. A non-detection could also mean we haven't looked for the right type of signals. Our telescopes aren't yet sensitive enough to detect faint transmissions from distant exoplanets. We may need to cross a sensitive threshold before a Cambrian explosion of discoveries can be made. Alternatively, if we are really alone, we should reflect on the unique beauty and fragility of life here on this planet. Righto, you're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. You can find that article in the astronomy.com website under the news tab. AI is helping hunt for extraterrestrial life, and it's found 8 strange new signals. All right, we're down to the last 5 minutes. I'll just briefly read this one out. It's a long article actually, but I'm just going to indicate a kind of an edited version. The James Webb Space Telescope, which has been a theme tonight, gets its own micrometeoroid forecast. It is essentially a meteoroid flux detector, although not intentionally. Even as James Webb Space Telescope is allowing astronomers to see inside vast distant galaxies, it also studying some tiny nearby objects, albeit inadvertently. These are micrometeoroids, tiny mysteries zipping through the solar system at lightning speed. They are far too small for scientists to observe directly in deep space, but they shouldn't be ignored. Micrometeoroids can pack quite a punch, as NASA's James Webb Space Telescope can attest. Since JWST's Christmas 2021 launch, engineers have detected more than 20 micrometeoroid impacts to the telescope. How's that? 20, I didn't know that. Engineers have detected more than 20 micrometeoroid impacts to the telescope. Only one notably hurt the observatory. The mission is adjusting its operations to reduce the frequency of micrometeoroid hits, but still the impacts themselves are perhaps the least expected data from the powerhouse new observatory. It is essentially a meteoroid flux detector, although not intentionally. Margaret Campbell-Brown, a meteor physicist at the University of Western Ontario, told Space.com. Although, of course, we're sad for them when their mirrors get hit by meteoroids, the JWST team briefly worried that it had underestimated the threat from these tiny particles in May 2022, when scientists saw a relatively large meteoroid hit on the observatory's massive golden mirror, even before normal science observations had begun. But by the time the observatory marked the first anniversary of its Christmas 2021 launch, the team's confidence had returned. Scientists had determined the worrying micrometeoroid was large enough that they wouldn't expect to encounter such an object more than about once a year, and engineers had determined that the particle managed to hit a particular vulnerable location. I'm just going to leave that article there because it does go on, but essentially astronomers are obviously addressing the fact that micrometeoroids are a bit of a problem for the James Webb Space Telescope, and that as a result of that, a science has come from it, and they're able to use the telescope as a form of a detector to get to try and quantify the amount of micrometeoroids that actually do travel through space. And they're like little bullets. They can be potentially very dangerous. But that's interesting. 20 micrometeoroids impacts to the telescope have already been detected. Quite interesting. All right. I'm just going to go straight to spaceweather.com. Excuse me. The solar wind is currently at 333.3 kilometers a second at a density of 4.25 protons per cubic centimeter. There are, and I've got a picture of this, I'll bring it up, the sun, good old disk of the sun. There are currently five sunspots on the disk of the sun as we speak. Sunspot AR3207 is growing, but it does not yet pose a threat for strong flares. The sunspot number is currently at 89, and the radio sun, measured at a wavelength of 10.7, which correlates the optical observation, the radio sun is currently at 134 solar flux units. The K index, the planetary K index, KP, is currently 1.00, considered quiet. And the 24-hour max KP figure is also 1.00, which is quiet, considered quiet. The solar flyby of Comet 96P. Some comets like it hot, especially Comet 96P. The 6-kilometre wide dirty snowball just flew past the sun, deep inside the orbit of Mercury, and survived. And there is a movie there that you can play of that. From the Solar and Heliospheric Observatory, SOHO, to see the entire flyby. Researchers working with the SOHO data say that they may have a surprise to share in the days ahead. Stay tuned. whether the comet survived going around the sun or not, I guess. And here's an image of the solar cycle as it is right now. Bring that up. So that's where we are for all us amateurs that are interested in the solar cycle, cycle 25. That's where we are at the moment. That yellow arrow that you see there, it actually says you are here. So the sunspot count hits a 9-year high. In a continued sign of strength for the solar cycle 25, sunspot counts just hit a 9-year high. This plot from the NOAA shows how the monthly sunspot number skyrocketed in January 2023. So we are definitely going to have a very exciting period coming up with solar activity. So for all you HF operators out there, the bands are going to real sparkle over the next 12 months or so. Originally, forecasters thought solar cycle 25 would be about the same as solar cycle 24, one of the weakest solar cycles in the century. Current trends suggest that solar cycle 25 will surpass that low threshold, and at least solar maximum is not expected until 2024 or 2025. So it has plenty of time to strengthen further, bringing X-flares, geomagnetic storms, and amazing auroras. So this then goes to our South Pole, bringing up the current auroral view over the South Pole. And as you can see, there's not much activity over the South Pole at the moment. The aurora activity is very, very faint and weak tonight. So, yes, it's all very quiet, isn't it? Just checking what else is on space weather. There's a lot of data. They do have a lot of information here to read. Take me an hour to go through, so that's why I don't. But I do end up on this one. Potentially hazardous asteroids, PHAs, are space rocks larger than approximately 100 metres, and that can come close to Earth more than 0.05 AU. None of the known PHAs is on a collision course with our planet, although astronomers are finding new ones all the time. As of the 3rd of February 2023, there are, or were, 2,326 potentially hazardous asteroids. 2,326 potentially hazardous. And you know, last weekend we did have a visitor that went past the Earth. It was discovered only a week before its closest approach to Earth. And would you believe that the closest approach that it made over the point of South Africa, directly above, was about 3,600 kilometres. I think that was the figure. Around 3,000 odd kilometres above the tip of South America before it took off into space. The close proximity to Earth, the gravitational effect of Earth actually has changed the orbit, apparently, by a small percentage. But the object was travelling in basically in the same direction as Earth, and it just skimmed the upper atmosphere of the planet. So that's a pretty close call for an asteroid that was only wasn't very big, about 8.5 meters in size. If it had have been on a course that impacted the Earth's upper atmosphere, it would have most likely just burnt up, big fireball in the sky, and probably produced a decent shockwave at the same time. But it just goes to show how there's a lot of objects out there that we don't know their paths, or haven't discovered them yet. Just thought I'd mention that. Anyway, this is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. We shall now conclude tonight's session, 5 past the hour. Thank you for hanging in and sticking with us, everybody. Thank you, Andrew, Don, Stephen and Ian, for calling in on the email address there. So vk3ekh@gmail.com. vk3ekh@gmail.com. So if you've got any articles you might find through the week that might be of some value to read out, by all means send us a link to those articles and we'll take a look. thanks Martin, VK7JH, and Remus for checking in on the Discord chat room as well. Very, very low activity up there tonight. So on that note, we shall conclude our transmissions on 1865 while it rains fairly heavily outside. I can hear the rain on the roof. And this is VK3 EKH. I didn't give any spiel about the society today, but more information about the society can be found from the ASV website at www.asv.org.au. If you want to find out more information about what the society is up to, www.asv.org.au is where to go. So we shall conclude our medium wave service, and we'll catch you all next week. There'll be a quick callback on 80 meters. There won't be any callbacks on 160. And yes, so this is VK3 EKH with VK3 CSJ on the microphone, concluding our transmissions on 1865 SSB. Good evening to all listeners on 160 meters. All right, so that's 160 finished, and I think, yes, I have to switch the speaker over. I don't hear what's on 80 meters. Excuse me for a sec. All right, we're now listening on 80 meters. I've got to get that fixed up. All righty, where's my pad and pen? I write with my left hand, so that's got to go there, and that's got to go there. This is VK3, not CSJ, well, I am CSJ on the microphone. This is VK3 EKH, listening on 80 metres for any stations wishing to check in.
VK3 Juliet Radio. VK3 Tango Juliet, yeah. This is Victor Killer 3 Kilo, Italy Sierra. VK3 DX.
Okay, we've got VK3JR, VK3TJS, VK3KIS, VK3SBX. Anybody else? Okay, g'day Martin. All right. Now, that's okay. Good. Strong signals tonight. Everybody is quite strong. VK3JR, VK3EKH. G'day, Frank.
Thank you for the usual great podcast. Always especially interested in space weather. Looking forward to even better times to come. Quite remarkable, great stuff. And I haven't had anything special to report. There will be missions tonight for those who are interested on 160 and 70 centimetres. And I wish everyone a great week. Thanks very much for doing it, Clint. VK3 EKH, VK3JR.
Yeah, good on you, Frank. VK3JR, VK3 EKH. Super strong. It is the strongest I've ever seen you. You're 25, averaging 20 to 25 to 30 over 9. I've never seen you 30 over 9. Maybe it's all the rain it's happening, but I don't know. But excellent signal tonight. Most impressed indeed. It'll be interesting to see how Steve on 160 tonight's coming through on 160. All right. Thanks, Frank. And I try to make the solar report always worthwhile. And of course, if I can get Tamitha up with her with the report, I'll play it. But there was no new report for tonight, so there it is. Jack up at Shepparton, good signal from you too. VK3 TJS, VK3 EKH. Go ahead, Jack.
Yeah, VK3 EKH, this is VK3 TJS. Good evening to you, Clint, and good evening to everyone that's checked in and listening, and happy New Year to you. First time in this year for me, so yeah, it was great to listen to you, and also I chime in on the internet to the YouTube channel, and it was good to see the diagrams and pictures and everything else, and it was just a new experience. And great night flights, really high cadence, just with huge signals, and your transmission all the way 100%. 20 of it, so it's very good. Talking about the subject of comets and meteors and all that kind of stuff, I got a very nice Christmas gift, and which arrived a little bit after Christmas, but that's okay. My lovely wife has arranged for a interesting book about a space gem that's arrived in Murchison some 50 odd years ago. And I found it that was delivered by the author of the book, and with a nice signature and nice message inside. So it was quite a surprise for me, and I'm in the process of reading that. I kind of knew about the meteorite and knew about its special status, and I've seen that in Melbourne Museum Underground, where we went probably 20 years ago or so to visit the place and see different gems and stuff and what have you. And I felt it in my hands and smelled it, so it was quite interesting. So I've got this nice book which I'm reading now. So thanks for the broadcast, it was lovely, and I'll catch up with you next time, please. VK3EKH, this is VK3TJS.
VK3TJS, VK3EKH returning. Very good, Jack. Yes, Australia is got quite a large number of meteor impacts. I remember reading somewhere that there was a book. I remember seeing a book that it opened up and it had the map of Australia, and it had marked on that map all the known impact locations of meteors. And I was actually quite surprised at the number. There's quite a lot. I can't remember particularly how many, but a lot of those impacts have weathered and maybe not totally visible if you were using Google Earth, for instance. But I know that there is plenty, and there are some that are still, like Wolf Creek Crater, for example, and the Henley meteor impacts up there just north of Alice Springs. I've been aware of the Murchison meteor impact, and we've actually got a meteor impact that's just down here in Cranbourne, but it's been weathered over the years, and of course the development of the suburbs here in Melbourne have gone over that area, I believe. But I know in Cranbourne somewhere there's a place where they've got the information about the meteor on show. Haven't been to it, but I must visit it one day. Anyway, very good. Sorry about that, I'm rambling. Thanks, Jack. Good signal from you too. You're 25 to 30 over 9, so coming through very well indeed. And okay on the YouTube. I think you said it was the first time that you were looking at the YouTube side of it too. So that's what it's there for. Thanks, Jack. Andrew, VK3KIS. Good evening to you, sir.
Cleaning up corrosion and that. So this is the first time I've been able to listen in this year. So hence the email. But I hope you're keeping well. And with all these meteorites hitting the earth and that, what amazes me is how that one in Arizona just missed the visitor center just by a few meters. Anyway, enough of the silliness. VK3 EKH, VK3 KIS.
Yeah, no worries, Andrew. VK3 KIS, VK3 EKH. I was actually concentrating more on the camera on your signal meter. I've got a second camera focusing on my radio with filming signal reports, so you can check it out later on YouTube how strong you were coming through. Anyway, dear. But nevertheless, very good. Yeah, just briefly, did you get any resolution on the telescope with Forgotten his name. Oh, anyway, you know who I'm talking about. Any resolution out of that situation, Andrew?
We're basically up to replace my telescope. The chap that contacted me wasn't able to help me. I've been working with Intel in Sydney, and we've got some equipment to set up. In fact, the OCA, the 8-inch telescope arrived this afternoon, and I've been checking it out this evening inside, making sure that everything fits. So, quite excited. It's got me in time to look for the green fuzzy balls in the sky. So I'm looking forward to that. Over.
Oh, that's fantastic, Andrew. That's good news, actually. I guess that's why I did ask the question. So that's brilliant. Well, let's pray. I use that word figuratively. Let's hope that the 14th and 15th of February is clear. The skies are clear and there's no full moon or no moon around, so that we can get a chance. I might even take out the Celestron that I've got here and see if we can see this meteor ZTF up near the constellation of Taurus. So yep. Okay, good. Let's just hope it's a cloudless night. Tonight's useless, of course, but there it is. It's the whole problem with the optical astronomy. You're very much dependent on the weather. Thanks, Andrew. That's a good update. Thank you for that. Across to you there, Steve. VK3SPX, VK3EKH.
VK3EKH, this is VK3SPX. Yes, hi Clint. Good show. I'm afraid I did miss most of it. However, my son came up with a friend just as it was just a little bit after it started up, so I did miss most of it. So I thought I'd better check in and say hello. I did hear a bit about the comet to start with, so I haven't done much astronomy lately, but I guess I'll have to dust off the telescope and have a look at this comet. Friends of the family are even saying, have you taken photos of the comet yet, Steve? And it's, bloody comet. But anyway, I'll have to normally into deep sky stuff, but I guess I have to make an exception for a comet that only comes around, one in 50,000 years or so. Anyway, you're a good signal, of course, 30 over 9, everyone's leaving in, and I can actually see your meter on my screen here, which is kind of cute, so I can see where I'm hovering. It's a little bit difficult, of course, because it's about 30 seconds behind real time, but interesting to see what I'm doing to your meter there. All right, that's about it, I think. Until next week, cheers and cheerio, and we'll see you next week. VK3EKH, this is VK3SPX.
Yeah, good on you, Steve. VK3SPX, VK3EKH returning. Yeah, not a problem. Look, I had to laugh when you say that. Damn comment. It's one of the reasons why I want to get an observatory set up, an optical observatory set up. So the damn telescope is ready to go at a moment's notice. That's all I want. It's too much of a hassle to set up a telescope. I mean, if you've got a good telescope that's computer controlled and all this sort of stuff, you need to set it up. It's like a learning process you go through every time. And I just want my dome, 3-meter dome, installed very soon. I don't know when, but it'll happen soon. And courtesy of the lads out at Sidereal Trading. And then set the telescope up. So all I've got to do is open the door, open up the shutter, and point in that general direction, and we're ready to go. And I can invite family, friends, anybody to come over and, come in and have a look through the telescope and see what I'm seeing. So it'll be fun, but not quite yet. I've still got a little bit of time to go on that one. Sometime in the next few months, hopefully. Thanks, Steve. All right. You've seen the signal. You're about to 20 over. Look at this. This is rain static on 160 meters. Just have a look at this. That you see that on, for those watching video, I've got the camera on my 160 meter radio, and you can see the rain static on the scope, the spectrum scope, and it's hovering 20 over 9 as I speak. Look at that. That's just rain static, and I can play it. I've just got to select the speaker to do that. All right, hang on. Oh, where are we? Did I select the speaker? Where is the speaker? Sorry about that, ladies and gentlemen, but there it is. That's the rain static noise on 160. It's horrendous. If you're trying to make a contact, it's quite hopeless. 80 meters should be okay. Yeah, no noise on 80, but it sets off 160 like you wouldn't believe. Sorry about that. Martin, VK7JAH. I hope you heard my rain static. Oh dear. VK7JAH, VK3 EKH. That's right, EKH. Oh, I'm tired.
Signal down here is very good actually. You're sitting about 40 over 9 and 5. Very readable. A little bit of noise in the background, but not too bad. Good broadcast tonight. Thank you very much. I'm looking forward to looking at comets. So I'm going to get out my 20 by 80 zone. I might put telescopes as well, a couple of telescopes and have a look as well. But I feel binoculars, I always enjoy looking at comets through binoculars. Somehow stereo vision just appeals to me when you're looking at comets. My favourite would have to be look north. It would still be the one that, to me, classically looks as perfectly like a comet as you could get. Although I have to say that from the point of view of the London Planetarium, the time of Halley's comet was rather spectacular. We had huge audiences and a lot of enthusiasm. So yeah, all good down here. Hearing you extremely well, and good to hear you tonight. I'm struggling a little bit with a few of the other stations in the background. Maybe the bearing in the noise a little bit. Then it sounds like you've got a fair amount of noise between me and you anyway. So, not too bad. But VK7JAH, cover.
Yeah, good on you, Martin. VK7JAH, VK3 EKH returning. I've got to remember not to be on the microphone here because I've got the gain up on YouTube feed a bit too much, and I'll be surprised I'm not distorting you on YouTube. So I've got to be careful there about that. Yeah, look, binoculars will work fine. Not a problem with that. But as you know, anybody who's used binoculars, it's hard to stabilise the binoculars, but it's for brief observations. You know, that's all it really is. So that's been my sole source of looking at the sky and studying. It was through a pair of 12 by 50 binoculars, but now I've got some decent telescopes, so I hope to be able to use the telescopes eventually, in due course, as they say. Anyway, thanks, Martin. You're hovering about 15 to 20 over 9, so fairly clear compared to normal. Good propagation tonight. I'm not sure how far it's going, but certainly the short skip is working very well. Is there any further stations wishing to check in? VK3 EKH.
VK3 Hong Kong.
VK3 Hong Kong. Good evening, Steve. You've picked the right night. VK3 EKH.
I know. I was really excited. And there you came. There you were. A few hassles to start with, but they were overcome. Anyway, I sent you a signal report, which you failed to acknowledge. Very, very disappointed in that. What was it? 25, I think I gave you. 25 over 9. And that was on 160, and on this your 30 dB over 9. Very, very strong. I'm using horizontal polarization at the moment. There you go. Over here, this is VK3HK.
Yeah, good on you, Steve. VK3HK, VK3CSJ. I'm broadcasting you over YouTube as well. So if I know you got a computer in the shack there, so just all you got to do is type in VK3CSJ in the YouTube search engine, and you'll find the live link. But you're about 40 over 9, almost equivalent signal to what I see to you on 160. But yeah, mightily strong, no doubt about that. Powerful audio and coming through very well. Now, if you sent your signal report to the email address that I specify for the broadcast, I can't see it. If you, as I say, any signal reports to the station for VK3EKH should be addressed to VK3EKH@gmail.com. VK3EKH@gmail.com. So that's where you should have sent that mail to. I suspect you didn't know that, but that's all right. I'm looking at my Gmail account now, and yes, I can see. Oh, there's a couple of reports there actually. Where are you, Stephen? Oh, there we are. I'm sitting here at the Radio Shack with a bottle of red, just fizzing with excitement and ready for the real thing. You have no idea how good it is to know that today is Friday and not Saturday. All tuned up and ready to go on 1865, Mr. B. Well, look at that. Oh, dear. Okay. And thanks, Wayne. There's a report there from another fellow. Good on you, Wayne. Okay, look, that's it. Excellent. But like I say, VK3EKH@gmail.com is the inbox that I have open all the time when I'm here at the station for ASV. Thanks, Steve. Any further comments you want to make, by the way?
Yes, indeed I do. You'll find my signal report there somewhere because, yes, VK3EKH@gmail.com. I got it off the ASV website. No problemo. I'll send you another email since you've finished your transmission. You were talking about the asteroid impact in Australia, so I did a little bit of a search, and I discovered something extraordinary, so I'll send you a link to it. I don't know whether you probably know across this, otherwise you would have mentioned it. Another thing which alarms me are these blooming things whizzing around up in space. The last thing I want to be doing is going on a spacewalk. You get one of them between the eyes, it'd be good night. Over.
Well, I did make mention to the micrometeoroids in the article on the James Webb Space Telescope just a moment ago. They're like bullets. They're literally flying around in space like bullets. There's a lot of them. Even as you say, even the International Space Station got hit by a micrometeoroid. The Russian section of the International Space Station, I think it was the Soyuz spacecraft. I think. Either that or the space station itself, I can't recall right now. But a micrometeoroid did puncture the outer shell, and there was some fluid venting into space. So I think they've got that sorted out by now, hopefully. But the James Webb Space Telescope has now been hit by 20. There's been 20 recorded impacts from micrometeoroids. So, they're so small that they're not causing any situation with the telescope up there, but of course the first impact was one that did puncture one of the golden mirrors, and that immediately sent alarm bells to all the astronomers thinking, oh my God, we've just got this multi-million-dollar space telescope in orbit doing its thing, and it's already under attack. So so we can only hope that they can get all the research done with this James Webb telescope before something serious occurs. But it's space environment is not a place to be, Steve.
Indeed, you either cook or you get fried with radiation, or you get one of these things between the eyes. Good night. Yeah. Anyway, look for this link which I've sent you. It's from the Australian National University. Okay, hitting 40 dB overnight at the moment, so those predictions which we were talking about earlier on about this cycle being pretty good, looks like it's panning out, 40 overnight, super duper. See you later, thanks for the broadcast. This is VK3HK.
Good on you, Steve. VK3HK, VK3CSJ, not EKH, not a problem. Oh dear, we'll probably hear you on the wireless tomorrow morning, the Coffee Break Net, maybe, but certainly Monday. Anyway, cheers, mate. Thanks very much for calling in. Much appreciated. It's good, definitely good signal from you. Okay, and of course Wayne, okay on the Raycull, 1217 being revived from the Too Hard basket. I can understand that well and truly, but thank you for the report, Wayne. All right, I'll just take one more listen if there's anybody else wishing to come in. VK3 EKH.
Oh, by the way, that static which you're getting on 160 metres, no sign of it here, so it must be local to you. Probably some sort of power line or something going nuts, but not rain static.
Oh, it's rain static, Steve. It only happens when rain just starts. I've sat here looking out the window, and it even sometimes it even starts before I see any rain happening. It builds up. I played it over the radio just a moment ago. It's a very distinctive buzz, which is broadband right across 160. I can actually see the frequency response of my antenna as a result of that, and it reaches to 60 over 9, 60 dB over 9. And it's a very, very powerful burst, but it then after a while, a couple of minutes, it just fades away to a very small buzz and then disappears, and then maybe a minute goes past and it will arc up again. But it's definitely rain static, a buzz. It's only there on certain rainy days, not all the time, but only certain rainy days. But I never hear it anywhere else. It's only on 160 over.
Okay, everything you've described, I agree with 100%. I take back my comments about it being some sort of localised. Well, it was localised because it wasn't happening here, but it's not power line. Yep, I get the same deal here. I don't spend all my life in the shack, but occasionally I'll walk past the shack and I'll hear this tick. And I'll think, what the devil is that? And then I realise it's the rain static building up, and the voltage is jumping between the plates of the variable capacitors. And not long after you hear that, it just goes to a constant arcing across. At that stage of the game, I'll get someone else to remove the antenna for me. And I hit for the shoulder. Over to you.
Oh, that's a nice thing to do. Go out and trick somebody. Or you hear this coming from the backyard. Oh, I got him or got her. Oh dear. Anyway, all right, fair enough. Yes. All right. Catch you later, Steve. Get to bed early, and make sure you feed the magpies in the morning. VK3HK, VK3CSJ.
No one commented on your haircut. What happened?
I got a cut. I don't know if you can remember how long it was, but I took 5 weeks off over Christmas. I'm back to work this week, as you know. But as of Monday, from Monday this week, my hair was down to here. I was constantly getting it out of my mouth. Look, there it is. That buzz is coming up on 160 right now. It's hang on, let me see if I can play it over. That's Steve, Mr. SL, in the background.
Yeah, I'm not sure which is the worst interference. the static. Oh boy. Yeah, that's it. I do remember your hair. I remember seeing you a couple of times at Hamfest a long time ago. And also, if you look back at the various things on YouTube, there's little pictures over there with the long hair. So it's certainly not long now.
Well, that's right. But I will grow it back. I'm not one of these people that regularly go to the hairdresser to get regular cut and keep it short. I just can't be bothered. I really can't be bothered. It only costs $20, and at least I think it was. But no, it'll grow long again. And it irritates me how short it is at the back. I can feel the breeze on the back of my neck. But it's when you lay your head down on the pillow that you really notice it. You sort of move your head back and to try and find a comfortable spot. I just have to get used to it. But I've always had long hair, always since I was a teenager. At secondary school, my hair just went long. So there it is. But I figured the first day back at work, I ought to look a little bit respectful, and with shiny black shoes. That'll all fade away in the next couple of weeks, of course. Anyway, thanks, Steve.
Years and years and years ago, when I was still working, I've been working at the same place for a number of years. And over Christmas, no, in fact, it wasn't over Christmas. It was just before we broke up for Christmas. I shaved my beard off, and I went into work, and no one recognised me. It was bloody incredible. So in the end, I introduced myself as Steve Bushell's brother. And I wanted to know if Steve had come in. And they said, no, he hasn't been in yet. I take it that people recognise you at work. Would that be the case?
Well, look, they like I say, it was 5 weeks ago that they would have last seen me at the Star Party. I mean, the Christmas breakup party, and the comment that's been picked up is that certainly it looks better. All the Asian ladies that mostly work there have all made the comment that that's better, Clint. But they've also picked on the fact that I look like my supervisor, not from the front, but Nick, our supervisor. He's an American chap, lived most of his life in New York, but of course now lives in Australia. He's been in Australia for a while now, but he's a funny bloke. He's got a very unusual sense of humour. But anyway, he has a very similar hairstyle to me from behind. And a lot of people have come up to me saying, geez, you look like Nick from behind. I think, oh my God, there's Nick. I better be getting back to work, or something like that. And it's funny. I can see it. It's the way that the hair's cut from across my neck, which I don't know if I can do this on camera. But there it is. That's how I look from the back. And apparently that looks like our supervisor at work. So I've been getting lots of comments that of that. I suppose that's a good thing. I don't know. But it's all going to grow back. It is all going to grow back. Over.
Okay, I'm just looking at you. There's a certain amount of latency. Looks very, very neat from behind. Very neat. You need to be demanding extra pay because
I am.
The amount of throughput in the joint is going to go up because all these people think that you're Nick. I've been demanding more money. Anyway, look, 23.39. You need to go and prepare to get into the sack, and so do I. So I'll catch you later. Maybe give you a call tomorrow morning if you're on 7.3. This is VK3HK.
Yeah, no worries, Steve. I've got to keep in mind the delay on YouTube. There is quite a bit of delays in there. I think it's up 10 seconds or something like that. So I keep forgetting about the delay. If we were going through the Melbourne TV repeater, the repeater is still not accepting pictures signals at the moment. But the Melbourne television repeater, it's still probably about a second delay from what I transmit up to the repeater to what gets transmitted back out. But I can live with a second delay. But the YouTube one is definitely a hassle if you're listening to me on 80 metres at the same time. Anyway, not to worry. I was going to say, the pay rise. Well, yeah, in a way, I'm working on it. As I mentioned today on the Coffee Break Net, I'm trying to go back to full-time work. So if I can get back to 5 days a week, well, that'll be back to my normal salary. So yes, there is a pay rise. Not a pay rise as such, but certainly an improvement over what I'm making at the moment. So I'm definitely hoping that they approve the 5 days a week scenario. I definitely need that extra salary coming through. Right now, it's not looking too good at all. I've been spending lots of money back and forth like you wouldn't believe. This Telefunken transmitter has been taking some money out of me, and there's a few things I've been buying off the internet. So I've got to put a stop to it right now until I can get back to full salary. That's another story. Cheers, Steve. VK3HK, VK3CSJ, EKH, whatever.
Okay. Yeah, there's about a 20-second delay, I'd say. At least 20 seconds between the real thing and what comes over YouTube. You definitely need to go back to work. I've been toting up, how much you've been spending, and I'm thinking to myself, that's why I sent you that email about the dome and the platform and the pillar. I'm thinking to myself, how are you going to pay for all this, let alone do it? Anyway, catch you later. Maybe pick you up tomorrow. This is VK3HK.
I'll work it out some way. I'll work it out. I've yet to determine the cost of the deck, the materials for the deck. I'd like to try and find out the difference between going with a metallic frame for the deck or a timber frame. So I've got to work that out. So that's going to happen very soon, in fact. Anyway, and I'll let you know. It'll be on the net, Coffee Net. I'll spiel that information. Anyway, cheers for now. Cheers, mate. Bye. Okay, this is VK3EKH, concluding transmissions on 3541 kilohertz. Thank you for listening, all those listeners out there, and we'll be back next Friday to do it all over again. This is VK3EKH, aka VK3CSJ, concluding transmissions on 3541 and the YouTube stream. Whew, and see you next week. Bye for now.
VK3CSJ to VK3SPX.
Yes, go ahead, Steve. What are the names?
Tim and Max. Tim is my son, Max is his friend.
Okay, g'day Tim and g'day Max. Welcome to the Radio Shack there of Steve's Shack. As you can see, I've got the wrong camera on. Hang on, oops, wrong mouse. There we are. Okay, so as you can see here, this is my Radio Shack behind me. And in fact, I'll put the other camera on because I can. This camera I'm on now is on a tripod, so I can't really move it. I apologise for the delay. It's on YouTube, so whatever I say here on 80 metres, there's going to be a 20-second apparently delay on YouTube. So bear with the delay factor. It's just inherent in the system. Where is the other camera? There it is. This is my portable roving camera. And so with this camera I can show you the rest of the radio station. So once the camera focuses, okay, these are the two transmitters I use for the broadcast. This is for 80 metres and this is for 160 metres, what I refer to as HF1 and HF2, and that's going to one speaker just at the top there, which I've got to fix up. Anyway, there's the computer station here. This is what I use for the the information that I read out during the broadcast, my astronomy broadcast. That's the inbox for my email, and that's the Discord chat window. Down there's the other part of the messy shack. You can see all my older equipment. That's all valve stuff in there. The ASU station, Geloso. You can see an old Italian Geloso transmitter in there, which probably doesn't mean anything to you. A usual mess, which I've got to try and tidy up. This is a couple of racks of equipment here, linear amplifiers and some television equipment. There's me. Sorry. There's the other side of the station. Trying to get the camera right. So there's a couple of HF radios there and VHF radios, and I've got to change the hand here. This is all VHF, UHF, 23 centimeters sitting in there. Spectrum scope come with that. All that's coming from that radio down in there. There's the mixer for all the audio side of it, and a couple other sub mixers for going into the radios here. And that's my TV transmitter just up here. It's a television transmitter, so I can transmit TV pictures over radio. And that's the big screen that I use up here for watching the ATV repeater. And I think that's about it, really. So that's the shack here. Oh dear. And that's the program that I use for all the video mixing that goes on. It's called vMix. So once I bring the mouse up to there, where am I? Here. I switch back to my other camera, just like that. So I hope they're impressed, Steve. Ham radio has been around for many, many years. It goes back to the 1920s, even before then perhaps, but it all started with people that were interested in tinkering in their back sheds and putting parts together and building radio receivers to be able to tune into commercial broadcast stations. But a lot of what we take for granted these days, like these mobile phones, all come from ham radio or early experimenters and pioneers who were like us, that tinkered in their back sheds and built and constructed things, and in often cases had to make their own components for things to work. So the hobby stays alive as it is today, and it's a fun thing to be able to use shortwave radio to communicate to stations around the world. It's all too easy to use the internet and mobile phones. People don't understand what's behind the technology in these mobile phones. So there it is. Was that enough, Steve? Is it okay? VK3 SPX, VK3 CSJ.
Maybe I just let them both have a quick word for you, and maybe their voice will wind up on the YouTube, which might be a little bit of a buzz bomb. If that's okay with you, Clint. VK3CSJ, VK3SBX.
Yep, go ahead.
G'day, Clint. Tim here. Just saying hi. At some point over the next many years, I'll have to get involved in some way, shape, or form.
Right. Well, yeah. Do so. The amateur, to get your license, the amateur license is progressively becoming a very easy thing to do. And once upon a time, the license you had to sit for was a written one. You had to know your subject material very, very well, and be very, very good with the English language, so that you could describe the operation of a circuit, how a receiver works and how a transmitter works and how a power supply works. Sometimes you had to even draw a circuit diagram to explain the theory of operation, and the amateur license was like that for a long time. It actually included Morse code. You actually had to learn to receive Morse code by ear, receive and transmit by ear correctly, which I've been all through. And but the average demographic for the amateur community in, well, pretty much the whole world really, but let's say in Australia, last I read, was around 60, 70 years of age. So as the old timers pass away, so to speak, there's no there hasn't been any new blood coming in the years gone by. So the numbers of the amateur radio fraternity have been slowly dwindling, and a lot of people can see that the future of the hobby being ultimately fading away. But there's been techniques and ideas to try and embrace the youth of today to the hobby, and the license these days is, of course, all multi-choice. There's no need to actually describe anything by writing or drawing anything. It's a multi-choice examination. And of course, they introduced the foundation license, which I think is a 25 question exam paper. And a lot of people use that as a stepping stone to get their advanced licenses. So the foundation license, which Steve can tell you about, is out there, and that the Morse code is no longer an issue. That the Morse code was waived back in, I think, the year 2000. So you don't have to worry about learning Morse code. That's totally up to you, because Morse code is still a big mode to use in the hobby. If you know where to tune in the shortwave bands, you can hear a lot of people still quite happy to use Morse code, 10, 15, 25 words a minute. It's quite musical. But that's, having said that, of course, you can either be a fellow that constructs and build things, or you can be a basic black box operator, where a lot of the equipment you see behind me here is all commercially made. And if you've got a few dollars, you can buy the stuff and have a fairly reliable setup station running. And boy, oh boy, you've only just got to look at Facebook. On Facebook, there's a number of ham radio pages dedicated to ham radio stations all around the world, and they show their shacks off like you wouldn't believe. It's there's one site that's just dedicated to, this is my radio shack. And I tell you, the Americans just love their shacks. The equipment is just mind-blowing, how much of it that they have. You think this is a lot. You think what I've shown you here tonight is a lot. It's nothing compared to what some stations are. But by the same token, there are amateur radio operators out there that are quite happy to have just the one radio in their shack. One radio, the speaker, a microphone, a map on the wall, and they're happy with that. That's their station, and that's the most simple arrangement. But you can actually buy kits. There are kits where you can build up these transceivers. They give you a circuit diagram to follow, and you can easily build a transceiver from following the circuit diagram. So your engineering background would help you go a long way to understanding how to build your own transmitter and receiver up using modern components, surface mount components and things like that. It's all out there, and in America alone, there's over 700,000 licensed amateurs. So, the hobby is still very active, and with the sunspot cycle increasing, the sunspot activity has a great influence on the Earth's ionosphere. And as the solar cycle peaks, the ionization that occurs in our atmosphere also conversely becomes more ionized, more active, and shortwave communications can be done on very low power with great success. So the next 12 months is going to look really interesting in that respect. But, you know, it's not just HF, it's not just shortwave. You've got VHF, UHF communications, you've got satellite communications. There's a number of satellites that are actually in orbit dedicated for ham radio operation. In America, in the northern hemisphere, there's actually a geostationary satellite that looks over the northern hemisphere 24/7, and they can run not only voice through this satellite but also TV, digital TV signals. There is a bit of a push to try and get the same sort of a satellite, a geostationary satellite for the southern hemisphere. So that'll be a great time when we have that satellite parked over our southern hemisphere. And of course, there's moon bounce. You can build a station to transmit a signal to the moon, and hear the signal come back. And there are stations dotted all around the world that are set up to do moon bounce. So you actually reflect a signal off the moon, and you have communication passively using the moon as a reflector. It takes some special skills to build that sort of a station, but there it is. So the hobby is it's not CB, mate. It's not Citizens Band. Don't get CB mixed up with the amateur radio community. It's two different things altogether. So you've got to have the bug, though. I always talk about this radio bug. You've got to have this bug to understand what it's all about. I think Steve understands that too. Thanks, Tim. VK3SPX, VK3CSJ.
VK3CSJ, VK3SPX. That's a fantastic rundown of amateur radio. You really should capture that one as well. I think you captured all aspects of the hobby. That was fantastic. What were you talking about, new blood? Well, I'm new blood. I'm new blood. I've only been doing this for about 9 months.
9 months?
Well, I'm old. I'm new old blood, being 67, so I'm probably not really the demographic that we're looking to get into amateur radio, but I'm still new, so I don't feel too bad about that. Tell you what I might do. I might just put Max on for a second, Clint, and he can say hello as well and wind up. So I'll just stand by 2 seconds and I'll put Max on. So Max, just hold the microphone down and talk with about this far away from his mouth. Hey Clint, it's Max here. Really cool to see everything and get a full detailed rundown. Cheers for that. Super cool.
No worries, Max. Good on you. Good to hear you. You're coming across the radio just like you're on the mobile phone. Just a perfect loud signal. You can watch this YouTube. I'm recording. This is all being recorded on YouTube. So as soon as I stop streaming, you can view this video easily on playback. So you'll be able to hear yourselves. I'm only picking up the audio through my microphone here, which is just tilt the camera down a bit. That's the microphone that I'm using that you can hear me on. So I'm only picking up the sound through the radio, so it's not direct patch. But you should still be able to hear yourselves pretty clearly on the YouTube stream without a problem. I can see the level here moving fairly clear, so it shouldn't be a problem. But yeah, g'day Max, good to hear you. And this is an incredible hobby. It can be very expensive to run, to operate, as in getting equipment, but it can also be relatively cheap. I've got 2 towers outside. There's 2 radio towers that I've got. So from the mechanical point of view, I have 2 what they call Nelly radio tower. They're 13.7 meters. Both towers are 13.7 meters high. They're 2-section towers. So the top section telescopes down into the bottom section. So there's a winch on the bottom, and you can lower the top section down so to about the 9 meter, about the 7 or 8 meter point, and then that sits on a hinge. And there's a secondary winch where you can actually tilt the tower over to ground level. So all the antennas that you have on your top of your tower can be maintained, worked on added or removed from ground level, or using a stepladder. But that's what's so great about these Nelly towers, is that they're telescopic and can be tilted over to ground level. Unfortunately, the people who used to make those towers are no longer around, and at this point in time we have nobody in this country that's making these radio towers that can be used for the amateur community. It's a bit of a shame. So normally these towers become available when an old timer leaves the hobby, and the tower becomes available. So I've got two of them. One's got big antennas on it, and the other one's got the smaller VHF, UHF antennas on it. And you can see these, if Steve knows what I'm talking about. If you go to qrz.com, type in my call sign VK3CSJ, you'll see pictures of a tidy shack, and you'll see pictures of the two towers where I am here in Narre Warren South. So there it is. There was something else I was going to say there, but it just went out of my mind. But anyway, there it is. Take it, Steve.
NBS, I think, is horribly expensive. Anyway, I haven't quite figured that out yet. Anyway, look, thanks very much for that. That's fantastic, Clint, and thanks for staying up and talking to the fellows here with that rundown of amateur radio. You said it was expensive too. Yeah, funny about that. Astronomical is pretty expensive too, Clint, as you're about to find out. Wait till you buy a few cool cameras and a few accessories and what have you, and you find you actually got two of the most expensive hobbies going. I don't know how that happened to me as well. All right, well, thanks very much, Clint, 73, and hope we'll talk again soon. Certainly talk next Friday. VK3SJ, this is VK3SPX.
Yeah, thanks, Dave. VK3SPX, VK3CSJ, and cheers to you there, Tim and Max. Thanks. Nice to meet your acquaintance. And Steve's right. It can be expensive, and I've got myself very soon. I will have myself a 3-meter scope dome installed in the backyard. And I just had to go with the most expensive dome, Rolls Royce of domes. But if you're going to get into astronomy in a serious way, just like this blasted hobby, it's a lot of dollars. So but that's another story. All right, cheers, Steve. Take care. Cheers, Max. Cheers, Tim. And have take care. VK3 SPX, VK3 CSJ.
Thanks, Clint. 73, VK3 SPX clear.
Okay. Nobody else there. So that's very good. Excellent. Good to hear Tim and Max on the radio. I hope the audio comes through fairly clear on the YouTube feed. I have to arrange for a feed through the mixer here to allow audio to patch through over the YouTube stream when I come to do the callback as it is. But in the meantime, thanks everybody who's been watching the YouTube stream. I'm sure there's a small number of people out there. I know that by the end of the following week, that grows to about 20 people that tend to view. So all very good. Thanks to Ian, Stephen, and Don and Andrew who's sent emails in today, and Wayne. Thanks, Wayne, as well. To the guys on the chat window there, Martin, Remus have come in, so very good. And if anybody is up at Parkes Radio Telescope, happen to be still up and watching me waffle on the YouTube stream, thank you for still watching. Let me know in the comments. What do? They go, let me know in the comments section below the YouTube thing, and there's a subscribe thing here. You can subscribe, and there's a bell thing too. Just ignore all that. That's a lot of crap. But anyway, so cheers everybody. Thanks for watching, and we shall Where's my colour bars? We shall fade to colour bars, and we'll be back next Friday. Oh, and for those that are still watching the YouTube thing, Jessica Watson's movie True Spirit has now hit Netflix. It's just a plug for the film because I'm a fan of Jessica Watson. So True Spirit, it's called True Spirit. It's just started to stream on Netflix, so give it a watch. It's a recount of Jessica Watson's solo non-stop navigation she did back in 2010, which I was a blogger, like many thousands around the world, and we sat there and every day wondering how she was going. So very brave for a 16-year-old girl to do that. Some say it was stupid, but she knew what she was doing. She was well prepared. And this new movie, True Spirit, portrays all that. So there it is. That's enough promotion for that. So cheers, everybody. I am going to fade to colour bars, in fact. Fade. Let's fade.